Question 1 says, sketch the image of ABCD after a dilation with a scale factor of 2, centered at point A. Okay, scale factor 2 and center at point A are two pieces of important information that we need to know. Label the vertices of your new shape with H, I, J, K, which is also important. That's going to be the labels of our new shape. Okay, so if our center is at A, we're going to start at A, and we're going to draw lines through each of our points here. Okay, use your straight edge to do this, and draw straight lines all the way through your points. Okay, now remember, when we do dilations off the grid, we're not going to get a ruler out and measure to make sure that it's a double. Okay, we're estimating. So I'm going to take the distance from A to B, and I'm going to estimate what double that side length would be. So I might say right here, and again, we're not calling it B prime, got to be careful there. Okay, let's try that again. Right here, and instead of B, we're going to call it I. I'm going to do the same thing between A and C. I'm going to picture double the distance. Okay, I might put C here, not C. Geez Louise. Okay, we would put that one there, and instead of C, we are calling this one J. And lastly, with D, I'm going to picture about double. I might say right there, and I will call this K. Our center never changes, so A and H are actually the same point, and then we can connect our points, okay, to have our new shape there. Okay, our scale factor was 2, so it makes sense that our shape is much larger, it's much bigger, so that checks out there. Again, it's not going to be perfect. It doesn't have to be perfect, okay, but you need to estimate each side is about 2 times the distance, since our scale factor is 2, and that your shape needs to look roughly the same. If you have a shape that looks completely different, we know we made a mistake somewhere and we should check that, okay? I'll do one more with you. Number 2 says, sketch the image of rectangle PQRS after a dilation with a scale factor of 1/4, centered at point Q. Label the vertices of your new shape with TUVW. Okay, so our center is going to be Q, and we're going to start by drawing a straight line through all the shape, or through all the points. Okay, so I'm going to draw a straight line here, a straight line here, and a straight line through S. Now 1/4, okay, 1/4 as a decimal is 0.25. I could find that out by doing 1 divided by 4. So I know that my shape's going to get smaller. And when you think about it, okay, if you think about it in relation to half, okay, if you have half a pizza or a fourth a pizza, a fourth would be significantly smaller. Half would be a big pizza cut into 2. You get one of the 2 halves. Whereas if you get a pizza and you cut it into fourths, that piece is going to be actually half that size. Okay, so it should be significantly smaller than half, about half of a half. Okay, again, it's not going to be perfect, but it should be less than half. I should be able to see that it's significantly less than half the distance. Okay, so between Q and P, I'm going to picture what, a quarter, a fourth, maybe picture halfway and go smaller than that. I might say it's right here. Okay, and instead of P, we're going to call that point T. I'm going to do the same thing between Q and S. I'm going to picture and maybe go half, and then maybe go half of that. It's maybe right there. And instead of S, we're going to call that W. I'm just following these letters from this letter to this letter, S, W. Okay, and then from Q to R, I'm going to picture a quarter of the way. 1/4, I'm going to say about right there. Instead of R, we're going to call this V. And then Q is not going to change. It's the center, so Q and U are the same. Now I can connect. And I still have a rectangle. It's just significantly smaller in size. Okay, so you should be able to do the same thing on the rest of these problems. Okay, using what we just did.